Okay, we're going to now talk about how we perform a sequence of transformations, put it all together to do some more complicated functions. They might look a little bit tough, but we can do it. All right, so here are some rules for how we combine transformations. First one, if you have a vertical stretch or shrinkage and a vertical shift, you first vertically stretch and then vertically shift. Okay, and the same goes for horizontal. First you stretch, then you shift. We're going to skip the second one for a minute because this is an easier form to think about. Okay, if you have something that looks like this, f of b times x minus h, we're going to have a horizontal shift and a horizontal stretch or compression. So first you stretch and then you shift, just like we did in the first one for vertical. Okay, stretch first, then shift. And if you just have horizontal and vertical shifts, it doesn't matter which one you do first. All right, so let's talk about this second case here. If you have f of bx minus h, it's a little bit hard to see. You know you're going to have a shift and a horizontal shift and stretch, but what is the value going to be? Okay, so here's an important first step if you have something that looks like that. F of bx plus p, okay, so that's kind of this case here, except they have a p instead of minus h. You have a coefficient in front of your x. You have to factor it out to be able to know what it is going to be. So here's what it should look like. You factor a b, whatever that coefficient is, out of those other two terms, right? If we multiply this out, we get bx plus p. Same thing we had here. Okay, so here's an example. F of x equals 2x plus 4. Let's see, our base function we're dealing with is x squared, right? It's going to be a parabola that's going to have some like a horizontal stretch or compression and a horizontal shift. Okay, but we notice, there's this coefficient in front of the x. I need to factor that out. Okay, so I'm going to factor the 2 out of these two terms. So I'm going to have 2 times x plus 2, right? It's equivalent. But now I can see I'm going to have a horizontal compression by a factor of 2 and a horizontal shift by a factor of negative 2. I'm going to go to the left by 2 units. Okay. Up here, I might have incorrectly thought I was going to shift to the left by 4. Not so. Okay. I'm going to shift to the left by 2 and have a horizontal compression by 2. Okay. And remember, we're going to compress and then shift. Okay. We'll do this one first and then that one. Let's look at a table. All right, we've got a function and they give us some input values and some output values for a function. And we want to make a table for this new function that looks like this. It's 2 times f of 3x plus 1. Okay, so let's think about this. We're going to have a horizontal compression by a factor of 3, a vertical stretch by a factor of 2, and a vertical shift up 1, right? So let's do them in that order. Let's start from the inside, the horizontal compression. So let's see, we started with input values of 6, 12, 18, 24. A horizontal compression means this input value I'm going to have to multiply by 3 to get that one. So I'm going to divide each of these inputs by 3 to get this. My outputs stay the same, right? So horizontal compression by 3. And now a vertical stretch by 2. My inputs stay the same, and my outputs, I'm going to multiply by 2. And then my last step is my vertical shift up by 1. So I just add 1 to each of these output values. And that would be my final answer. What if we have a graph? Okay, we start with this graph of f of x, and we want to to transform it to represent this new function k of x. All right, well, let's think. We have f of 1/2 x plus 1 minus 3. So it looks like we're going to have a horizontal shift and a horizontal something, compression or stretch, but we can't quite tell what they're going to be yet. And then we'll have a vertical shift by negative 3. All right, so this is that case where we have a coefficient in front of x. So the first thing we need to do is down here. I can't point or else it covers it up for you. Sorry. We need to factor that 1/2 out of that inside expression. Right, so the right side of the equation, you can see it's 1/2 times x plus 2 minus 3. Aha, perfect. Now we know we're going to have a horizontal stretch by a factor of 2, and then a horizontal shift to the left by 2 units, and then finally a vertical shift down by 3. So first, we're going to horizontally stretch by 2 because we have a 1/2 on the inside of the function. So let's see, before it looked like this. We went from -2 to 2. Now we're stretched it to go from -4 to 4. Okay, let's go back. Let's see, the next thing we need to do is a horizontal shift to the left by 2. So we stretched it, and now we shift to the left to go from -6 to 2. And then the last thing we need to do is shift it down by 3. And that would be our final graph. Right? So the first thing was we did the stretch or compression. Next, we shifted horizontally, and last we shifted vertically. Okay? So combining these transformations can get a little tricky, but if you remember those rules, you stretch or compress first and then shift. It's going to be really helpful. Okay? And your homework will give you some practice doing it as well.